In this video, we will dive into the 4 special cases outlined by ACI 318 in example 6.4. At this point, you should have gone through the equations from the previous lecture and set up your, it doesn't have to be Excel, but Excel is what I've used. So Excel spreadsheet with all of the terms calculating all the way through your axial load and axial capacity and moment capacity. And then throughout this video, these 4 conditions will help round out some of the values for that interaction diagram. So condition 1, the bottom steel strain is 0. This is where the maximum strain at the extreme compression fiber is reached in the concrete as 0.003 meters, shown in the diagram below. First thing we do is back calculate C using the strain compatibility equation 10.2.2. This can be rearranged, the strain compatibility equation from the code, such that C equals ECU times D1 over negative elastic modulus, or negative ES1 plus ECU. In this case, ES1 is 0, as stated above, so C equals D1, which is that distance to the bottom steel. Now, back calculating C and setting ES1 to 0, we can use the same equations from the previous video to calculate all of the terms needed to get axial and flexural capacity. This is why it's important that you've done this all out already and got it all figured out. I have a photo posted in this module so that you can kind of check your work, make sure that this isn't what your numbers should be, but make sure the signs are correct. Then we'll do the same thing for conditions 2 through 4, with the bottom steel strain as the only term changing for each condition. So in condition 2, the bottom steel strain is half the yield strain. In this case, we can calculate the yield strain as yield stress over elastic modulus and then divide by 2. Sorry about that. And then we'll use the same strain compatibility equation rearranged to calculate C, and then go through the same equations after calculating C, the same equations get back to axial capacity and flexural capacity. For condition 3, the bottom steel strain is equal to the yield strain, or at its limit for a compression controlled section. So we'll just take that strain as yield stress over elastic modulus. In condition 4, the bottom steel strain is at its limit for a tension controlled section. So we'll take that ES1 to be 0.005. And we'll just give a unit to that.